There are two things I love about research. The first one is that I love thinking about new ideas. I can think about, very specific ideas about reactions or much broader ideas about concepts and visions. But the beauty of academic research is I can think of an idea and then I get the chance to try that idea out. And of course, linked to that is, the team that I work with. And that's really the other thing that I love about research is working with talented, creative and motivated young researchers, PhDs and postdocs, and to try to help to shape them into the outstanding independent researchers that I hope they will become. I'm interested in how we can use synthetic chemistry to address societal problems such as the treatment of disease. My group tries to invent catalyst-controlled reactivity concepts that enable selective activation and bond formation within organic molecules. We have three major research themes in my group, which are all focused around the development of new chemical reactivity for synthetic chemistry. The first one is in synthetic catalysis, where we're trying to develop new reactivity concepts based on areas like photoredox catalysis or CH activation that really help us to solve and fill the gaps in the current limitations of synthetic chemistry, which will enable us to make small molecules such as drugs or natural products. In the second theme, we're interested in an area that I call synthesis-driven chemical biology, and this has similar roots to the first theme in that we're trying to develop new reactivity concepts, but this time we're trying to bring these methods to bear in much more complex environments, in biomacromolecules such as proteins or nucleic acids. We're really excited about this project which allows us to modify genomic double-stranded DNA at a position which is epigenetically modified. Before this point, there's no way that you can do this chemically, but now this tool might allow us to open up opportunities to do new chemistry that understands the role of these very important epigenetic modifications. Finally, we're interested in developing what I call synthetic technology. This is trying to bring to bear new methods in the technology side that can help chemistry. So in particular, what we're very keen on doing is developing platforms which allow us to conduct potentially thousands of reactions at once and analyze those reactions so that we can interrogate a chemical problem much faster than we were able to do with conventional methods. I think there are probably three major impacts of our research. Firstly is that we invent new ways to make molecules, and then other people in other areas of research can use these methods to help them make the molecules that they wish to make. So that creates impact in its own right. The second is that our research, I think, changes the way that people think about making molecules. They can make different strategic decisions based on the chemistries that we've developed, which will hopefully, again, advance their lines of research. And thirdly, and perhaps the most important impact of the research that we do, is the people that we train. These people will do great research when they're in the group, but of course when they leave the group, they go on into academia and industry or other careers, and they create impact through their own endeavors and research. And I think actually probably that has a bigger impact than everything else we do, because we train a lot of people and they can go on and do a lot of different things. My group is really fortunate to be supported by outstanding facilities here at Cambridge. And on top of that, we have a fantastic new laboratory which is equipped with really state-of-the-art analytical facilities, and so actually we have no excuse not to try and do good science. But most importantly, it's occupied by a really fantastic group of people through the PhDs and the postdoc researchers that I work with. My team is talented, they're creative and they're motivated, and they love doing chemistry. And they're constantly in pursuit of developing synthetic chemistry that can really try and make a difference to research, not just in chemistry, but also in wider problems in society, and probably most specifically into trying to help people develop new drugs that can treat disease.